This is just a short little video to talk about tree diagrams and Venn diagrams. These are tools that we use when the information is kind of complex and it's hard to think through all the scenarios. What if I put that cookie back in? What if I don't? What if there's 5 different kinds of cookies in there? Something that is a little bit more complex. And so we're going to first talk about a tree diagram. It consists of branches coming out that have different outcomes possible. So here is an example. I'm just going to move my head away. And this is about a bowl, an urn, a vase that has 3 red marbles and 8 blue marbles. So if I first draw a marble, we can easily, find those numbers, the blue and the red, the probability of drawing one. But then after that, it gets a little dicey, okay? Without replacement, we kept those marbles out. What happens next? Well, if we did draw a red one, then we have the same probability of a blue, but we have a reduced probability of a red because we've already taken one of those out. And you notice the denominator is now 10. There were only 10 remaining. And then from each of those scenarios, I can have other scenarios. So the probability of choosing a red, or a red then blue, and it just branches out from there. So that's why it's called a tree diagram, because each time, each one's going to turn into 2 different branches. 1, 2, and this one actually has 2 different ways of doing it. This percentage that they give right there is getting a red and a red, but it's going to branch out into more and more little branches. So that's a tree diagram. The other thing that we want to talk about, the other kind of diagram, is a Venn diagram, which is used often, and you've probably seen many of these. Its pluses, one good reason to use it is because it can talk about the entire space. Many don't draw this box around the Venn diagram, but when we draw this box around it, we're actually talking about the entire population then. Not all of it has to be included in either A or B option, or in this middle option here. So let's just look at an example with a Venn diagram. Here we have a junior college, and 40% of the students at this college belong to a club, 50% work part-time, 5% both work part-time and belong to a club. But that does not take into account all 100% of the population. And so we have this box that is on the outside here. And 15% of the students don't belong to anything. And how do we get that 15%? Well, if you remember, when we did our addition property, we have the probability of A, meaning that they belong to a club, and B, that they work part-time. And we have to subtract that overlapping area. I think a Venn diagram is very good to demonstrate right there visually that we need to subtract that area, or we're going to end up with more than we have students, right? So if I add up the 40% and the 50%, I get 90%. Subtract the 5%, I get 85. I need 15 more percent to complete my population. So 15% don't do either of these events, the club or the work part-time. And I like the box on the Venn diagram because that tells me something as well. So that is how we use Venn diagrams and tree diagrams, and hopefully that will help you as you do some of the more complex calculations.